There are creatures that ruled with teeth, creatures that ruled with speed, and then there was one that ruled with silence. It did not charge, it did not roar, it watched, a long neck cutting through black water, slowly, deliberately, like something that knew it had no rival. For over 200 million years, this animal drifted through ancient seas, not chasing chaos, but controlling it. Fish scattered when its shadow passed. Reptiles vanished beneath the surface without warning. The ocean itself seemed to part around its presence, and yet, the strangest part of its story begins long after its extinction, because centuries ago, in a quiet Scottish lake surrounded by fog, witnesses claimed to see a shape rising from the water, a shape that looked impossibly familiar, not just unfamiliar to them, but impossible to modern science. So the question remains, did this ancient ruler truly vanish, or did something survive where we least expected it? Plesiosaurus lived nearly 200 million years ago, during the early Jurassic period, a time when Earth was warmer, wetter, and dominated by reptiles that ruled both land and sea. At full size, many species of plesiosaurs measured 10 to 15 feet long, roughly the length of a modern pickup truck. Some of their distant relatives grew even larger, stretching beyond 30 feet, rivaling the length of a city bus. But size alone was not what made them remarkable. Their world looked nothing like ours. Vast inland seas covered large portions of the continents. Shallow coastal waters stretched for miles, warmed by thick, humid air and fed by rivers carrying nutrients into the ocean. Coral reefs formed dense underwater cities, filled with fish, squid-like creatures, and armored marine reptiles competing for survival. From the moment they hatched, young plesiosaurs entered a dangerous world. Fossil evidence suggests many species likely gave birth to live young, rather than laying eggs on land, meaning newborns were already swimming within minutes of entering the water. Instinct guided everything. Their long necks allowed them to scan the water ahead without moving their bodies. Their wide, paddle-like flippers worked in synchronized motion, similar to the underwater flight of modern sea turtles, allowing smooth, energy-efficient movement across long distances. Even at an early age, survival depended on awareness, because in Jurassic seas, even the hunters were being hunted. Plesiosaurus did not evolve to chase, it evolved to control distance. That difference changed everything. Most marine predators rely on speed, sudden bursts, violent lunges, explosive attacks. But over millions of years, plesiosaurs followed a different path. Their bodies flattened, their flippers widened, their movement became smoother, more deliberate, almost effortless. Scientists believe their four flippers work together in synchronized strokes, creating lift in the water much like penguins flying underwater today. Not frantic motion, but steady propulsion, reliable, efficient, built for endurance rather than bursts of chaos. And that endurance meant presence, a predator that can stay in the water longer, travel farther, wait longer, eventually becomes unavoidable. Its hunting style reflected that patience. Rather than crashing into schools of prey, Plesiosaurus likely approached slowly from below or behind, keeping its heavy body distant while extending its long neck forward. The strike itself would have been sudden, not from speed, but from reach. Picture walking through shallow water. You check what's ahead, you scan the surface. But what if danger didn't come from in front of you, only from beneath? That blind zone, the space you cannot see, is where Plesiosaurus held its advantage. Its prey included fish with reflective scales, squid-like ammonites drifting in spirals, and smaller marine reptiles navigating reef systems. Many of these animals depended on tight group movement to survive. Staying close meant safety. But long-necked predators break group safety. A single precise strike could reach into the center of a school without disturbing the rest, removing one target before the group even reacted. That efficiency mattered, because survival in prehistoric seas was not about strength alone. It was about conserving energy in a world where every hunt carried risk. Larger predators roamed the same waters. Competition never disappeared. And over time, creatures built for patience often outlast those built only for speed. That was the quiet power of Plesiosaurus. Not overwhelming force, but controlled, repeatable success. And in ancient oceans, consistency was often deadlier than violence. Most fear does not begin with what we see. It begins with what we lose sight of. Water takes vision away first. A few steps into a lake, your feet vanish beneath the surface. A few steps farther, your knees disappear. Soon, Even your own body becomes unfamiliar to you. That loss of control is ancient, older than humans themselves. Modern animals still use the same conditions that once favored Plesiosaurus. Crocodiles wait along riverbanks without movement for hours. Leopard seals patrol Antarctic waters, drifting just below the ice, watching breathing holes where prey must eventually surface. Even large fish remain motionless in shadow, conserving strength until opportunity becomes unavoidable. None of them rush. None of them waste motion. They wait for certainty. Fossil studies of plesiosaur neck joints suggest something unsettling. The neck was not built for violent whipping motions as once imagined. Instead, it allowed controlled bending, stable movement, and careful positioning. Scientists now believe sudden chaos was not its method. Accuracy was a measured strike, a controlled correction, a movement repeated thousands of times across a lifetime, and repetition creates reliability. Recent biomechanical modeling has suggested that plesiosaurs may have hunted in dim, cold environments, not just warm tropical seas. Evidence from preserved bone chemistry indicates some species tolerated lower temperatures than previously assumed. Cold water changes behavior. Animals slow down. Reaction times weaken. Muscles fatigue faster. Predators adapted to cold become patient by necessity, and patience is where fear deepens. Because the most unsettling predators are not the fastest ones. They are the ones that remain present without being noticed. Consider the environments that remain difficult for humans to fully search today. Deep lakes with steep walls, water systems fed by underground channels, regions where sunlight never reaches the bottom. Sonar surveys have mapped large portions of these places, yet gaps remain. Blind corridors of stone and sediment where instruments struggle to interpret shape from noise. Scientists studying freshwater systems often encounter readings they cannot immediately explain. Drifting debris, unexpected movement patterns, temperature layers that distort signals. Most of these mysteries have ordinary explanations, but not all questions disappear easily. One ongoing scientific question surrounding long-necked marine reptiles remains unresolved. How did they maintain stability while hunting with such extreme neck length? Computer simulations suggest the neck may have functioned as a slow-moving targeting tool rather than a weapon, extending reach into areas the main body could not safely approach. If correct, that design would not produce dramatic splashes or violent disturbance. It would produce something quieter, a slow disturbance, a brief ripple, a movement easily mistaken for nothing at all. And that possibility leaves scientists with one final, uncomfortable thought. Not that such creatures still survive, but that animals built for patience often leave the fewest traces behind. For most of its existence, the oceans were predictable. Warm currents followed familiar paths. Shallow seas supported endless chains of life. But stability in nature is temporary. Over time, the waters that once sustained Plesiosaurus began to shift in ways no single animal could control. Temperatures changed slowly. Coastlines retreated. Entire feeding grounds disappeared beneath layers of sediment or dried into isolated basins. Nothing dramatic at first, nothing sudden, just small losses, accumulating year after year. The oceans that once supported vast reptile populations began to change. Continents shifted slowly across the planet's surface. Shorelines moved, sea levels rose and fell. Entire coastlines disappeared beneath sediment, while new waters formed elsewhere. With those changes came competition. New predators appeared, faster hunters, larger-bodied reptiles with crushing jaws and stronger bursts of speed. Creatures like mosasaurs would later dominate many marine environments, filling ecological roles once shared with older species, not through sudden violence, but through gradual replacement. That is how extinction often works, not in one catastrophic moment, but in a long sequence of small disadvantages. Food becomes harder to reach. Prey changes its behavior. Water temperatures shift just enough to disrupt breeding cycles, and over generations, survival becomes less certain. Fossil records show that long-necked plesiosaurs continued to exist for tens of millions of years, adapting repeatedly as conditions change. Some species grew larger, others became more specialized, but adaptation has limits. Eventually, near the end of the Cretaceous period, around 66 million years ago, the world experienced one of its most violent turning points. An asteroid struck Earth. Not in legend, not in myth, but in measurable reality. The impact triggered wildfires across continents, darkened the sky with dust and ash, and disrupted the sunlight that supported ocean food chains. Plankton populations collapsed, marine ecosystems weakened from the bottom upward, and when the base of the food chain disappears, even the most efficient hunters cannot survive. Plesiosaurs did not vanish because they were weak. They vanished because the world that sustained them vanished first. Cold water grew colder, food became scarce, young failed to reach maturity, and slowly, generation by generation, their numbers thinned until one day, somewhere in an ancient sea, the last of its kind swam without knowing it was alone. No witnesses, no struggle recorded, no dramatic ending, just silence beneath dark water. Today, their bones remain locked in stone, long neck vertebrae arranged in patient rows, flippers preserved in the positions they once used to move through ancient oceans. Not monsters, not legends, but animals that lived, hunted, reproduced, and disappeared according to the same rules that govern life now. And their story leaves behind a quieter truth than most myths suggest. Dominance does not guarantee survival, not intelligence, not size, not patience, because in the history of life on Earth, even the most perfectly adapted creatures are only temporary.